back to Spring Into Math Babe. Today's lesson is on angles of polygons. Let's go ahead and get started. So we've learned about interior angles and exterior angles, parallel lines, transversals, triangles, and now we're going to take a look at the different angles of different types of polygons. So a polygon, let's start with the basic definition, which is a closed plane figure formed by 3 or more line segments that intersect only at their endpoints. Now we have a really nice graphic here. I suggest pausing the video and copying down this graphic as it's very useful. We have triangles, quadrilaterals, pentagons, hexagons, all the way up to a decagon, which has 10 sides to it. Now a stop sign is a hexagon and it has 6 sides to it. So you will see these types of polygons all over the place in your everyday life. So let's take a look at what's called a convex polygon, which is a closed plane figure where every line segment is connecting to any 2 vertices. Now here's an illustration that represents this. You can see here in our green and black image that we have our convex polygon. It also lets us know that all interior angles of this convex polygon are less than 180 degrees. This is a very important factor when we're looking at convex polygons. Now, there's another type of polygon, it's called the concave polygon. Very similar in terms of how it's said and spelled, but it is a little different. So that's a closed plane figure where at least one line segment connecting to any 2 vertices lies outside the polygon. So here's your concave polygon example. At least one interior angle is greater than 180 degrees. Now, the previous type of polygon we talked about was all interior angles were less than 180 degrees. So the big major difference here is that one of these angles is actually larger than 180 degrees. So how do you find the interior measures of polygons? Well, the sum, which can be represented by the variable s of the interior angles, measures the polygon with n, which is the number of sides. So here's our equation or our formula that we can use to find out what we're looking for. So here it is, written in 2 different ways for you. S equals parenthesis n minus 2, close your parenthesis, and then multiply that by 180. We also wrote it in the way that s equals n minus 2, and instead of putting the actual time symbol, I put a little asterisk there because sometimes in your math book you'll see it represented in a different way. I want to make sure you understand that that also means to multiply by 180. So here's an example. Here's an everyday street sign we would see, especially when you're going to a school or going on a crosswalk to cross the street. So how many sides does this shape have? Well, it has 1, 2, 3, 4, 5 sides. So remember the number 5 as we're going to use it to insert into our formula to solve the problem. So our formula is listed here on step 1. It says s equals n minus 2 times 180. Now, remember that 5-sided figure we just saw? Well, n is the number of sides, so let's insert 5 for the variable n. So we have s equals 5 minus 2 times 180. So we're going to go ahead and subtract. 5 minus 2 makes 3. So we have s equals 3 times 180. So we multiply those 2 out and we get 540 degrees. So that 5-sided shape has a total interior angle degrees of 540. So let's take a look at this example. We're asking you to find the missing angle here. So first of all, how many sides does this have? Well, it has 1, 2, 3, 4, 5 sides. Now, we just solved in our previous problem the 5-sided shape had 540 degrees. Well, we need to double check to make sure this is true. We have to prove that this is true. So pentagons again have 540 degrees. So our angles we have are 68, 121, 103, and 85 degrees. We're looking for that final 5th angle measurement. So how do we do that? Well, because we know that the total number of degrees is 540, we can simply add up what we know, 68 plus 121, 103, and 85, and we can get 377 degrees. Now, we have 377 plus x equals 540. Remember that 540 is our total number of degrees. So we need to subtract 377 from both sides of our shape, or our equation. And when we do that, I get the missing angle x is worth 163 degrees. So all 5 angles add up to 540, and we have our 5 angle measurements, 68, 121, 103, 85, and finally that 163-degree angle that we just solved for. Now, here's something interesting. Exterior angle measures of a polygon. Angles 1 through 4 have to add up to 360. Now, that's a little strange because when we think of 360 degrees, we think of a circle, not a polygon. But here, let me show you why this is true. So here's an example or a proof. I have a basic square here, a four-sided polygon. And we actually have the perfect 90-degree angles listed here because it's a square. So each corner makes 90 degrees. Well, if I extend my lines and have some exterior angles, I'm also creating secondary right angles. Now, 4 sides to a square, so 4 90-degree angles. Well, 90 times 4 makes 360. So we have just proved that this is true. So in review, remember, a polygon is a closed plane figure formed by 3 or more line segments that intersect only at their endpoints. The formula for finding interior angles of polygons is as follows. S equals n minus 2 times 180. Remember that n is the number of sides. So if it's a 7-sided shape, go ahead and insert 7 in for n and follow the formula. Go ahead and rewatch if you missed anything. Catch you next time.